Good morning, 11th class. Today we will study about blackbody radiation and Planck quantum theory. Okay, in earlier video we have learned about EM. It's an electromagnetic wave theory of radiation, or either you can say electromagnetic radiation. Okay, now according to that theory, I think you know that EM wave theory believed in the continuous generation of energy, but this theory was explained the phenomenon of that diffraction, either it's an interference, but this theory was failed to explain some of the phenomenon like black body radiation and photoelectric effect. So actually this black body radiation photoelectric effect, they generally shows the particle nature of light. EM theory believe what, that is the wave nature of light, but this theory believe that one is, or either you can say that Planck quantum theory and black body radiation, this shows that light have a particle nature. Although later on we will study that light in some cases light have particle nature and as well as that one is wave nature. That's why we said light shows dual nature. That we'll study later on. But before I'll explain this thing, that actually black body radiation is related that what happened when we heat a body. Then what happened? Before I'll explain that thing, first of all you should know what happened when light is passed through matter, or either you can say either it's some sample or something. So what happened when white light, light is passed through a body, or either it's a matter, it's the same thing. Now just see, suppose this one is a matter. Any body you can take, that one is a matter, because matter, you know, anything which occupies space and have mass. Now that we have already studied in earlier classes also, that one is when we pass light through a prism, then it gives what, that one it gives vigor, because it is split into different colors. Why it happens? Because that again, that white light, this have a different wavelength. It emit radiations of different wavelength. It's just see lambda 1, lambda 2, lambda 3. That one is different wavelength. And what happened? Suppose these light pass through a matter. So three possibilities are there. Now just see, maybe this matter absorbed some of the wavelength, your light of some wavelength absorbed by this body. Maybe another condition is that reflected by this body. Some of the light wavelength of light, that one is reflected by this body. And last one is, maybe possibility is there, that one is related to transmission. That this one is, this body transmit the light of some wavelength. Actually now in this one, this reflected light, whatever color we are seeing या जो भी चीज़ हम ऑब्जर्व कर रहे हैं, that one is mainly because of this one reflection. Actually what happened, that one is that white light, that one is absorbed by this matter. Maybe some is absorbed and some one is reflected. So whatever light is reflected by this matter or this body, that one is responsible for color. Now suppose you can take any example. Now just see, if you will see, just see the color of hand, this one is white. Whatever is the color, either it's a skin color, either it's a black color. So we are able to see that particular color because that light of that particular wavelength is reflected by our body. That's why we are able to see that particular color. So that is because of this reflection. That one is responsible for color. Now what happened when we heat a body? अब इसमें ये तो एक कंडीशन हो गई कि व्हाट्स द प्रोसेस या सिंपल व्हेन वी पास अ लाइट थ्रू अ बॉडी, देन थ्री पॉसिबिलिटीज आर देयर. नाउ सेकंड कंडीशन इज दैट व्हाट हैपन, या सेकंड क्वेश्चन इज व्हाट हैपन व्हेन यू हीट अ बॉडी. नाउ जस्ट सी what happened. Suppose this one is any, either you can take any metal or anything. When you heat it, generally we are taking example of metal. Now when you heat it, this one is a heat source, then what happened? This substance emit radiation of different wavelength. Just see lambda 1, lambda 2, lambda 3. Actually you can say that it emit radiations of all wavelength. जितनी भी होंगी ये थोड़ी सबकी क्या करेगा, वेवलेंथ को एमिट करेगा. नाउ ऑन दिस बेसिस वी दिस वन इज, यू कैन अंडरस्टैंड विद वन एग्जांपल. सिंपल थिंग, कभी हैव यू सीन दैट वन इज कि व्हेन वी हीट आयरन, ठीक है, लोहे को कभी गर्म करके देखना. ओके, व्हेन यू हीट इट दैट एट पर्टिकुलर टेम्परेचर, ठीक है, देन द कलर इज रेड. ओके, व्हेन यू heat it more, okay, more high temperature, okay, maybe the color is blue. Okay, so it means that different that one is when you heat it, then it gives what, that one is it emit radiations of different wavelength. Okay, and now again one question is कि you will ask that thing, this simple thing, that one is कि अगर हम इसको हीट कर रहे हैं और ये सारी रेडिएशंस को क्या कर रहा है, एमिट कर रहा है डिफरेंट वेवलेंथ की, तो वाई वी आर एबल टू सी दैट पर्टिकुलर कलर, रेड, ब्लू या वट एवर इज द कलर. ओके, हमें खाली वही क्यों दिखाई दे रहा है. ओके, एक्चुअली व्हाट हैपन, इट एमिट रेडिएशन ऑफ डिफरेंट वेवलेंथ. ओके, बट वी आर एबल टू सी ओनली दैट कलर. ओके, जिसकी वेवलेंथ क्या होगी, जिसकी रेडिएशंस, जिस वेवलेंथ की रेडिएशन सबसे ज़्यादा एमिट होंगी, वी आर एबल टू सी ओनली दैट कलर. ओके, दैट्स वाई. ओके, इन केस ऑफ दैट वन, मे बी इन दैट पर्टिकुलर एट दैट पर्टिकुलर टेम्परेचर, ओके, मे बी वो रेड वाले की क्या कर रहा हो, वेवलेंथ सबसे ज़्यादा एमिट कर रहा हो रेडिएशन. ओके, दैट्स वाई वी आर एबल टू सी दैट रेड कलर एट पर्टिकुलर टेम्परेचर. आफ्टर दैट एट मोर हायर टेम्परेचर इट कलर changes to blue. Okay, now just see, this one is a intensity, this one is a graph, it's a between intensity and wavelength. Now what happen when we heat a body, so simple, different that light is, yeah, radiation is emitted of different wavelength. Okay, but we are able to see color, which one, which shows lambda max. lambda max मतलब जिसकी wavelength कैसी होगी, सबसे ज़्यादा होगी, that one is known as, ज़्यादा मीन्स जिस भी वेवलेंथ की रेडिएशन सबसे ज़्यादा एमिट होंगी, वी आर एबल टू सी ओनली दैट कलर. ओके, तो दिस वन इज लैम्डा मैक्स. ओके, तो सिंपल, इन केस ऑफ ब्लैक बॉडी रेडिएशन, उसने भी लगभग यही वाली चीज़ थी, सिंपल. तो व्हाट इज ब्लैक बॉडी रेडिएशन, एक्चुअली एन आइडियल बॉडी विच एमिट्स एंड एब्जॉर्ब्स रेडिएशन of all wavelength or frequency, that is known as black body, and the radiation emitted by this body is called black body radiation. Okay, now in that case also, when we heat that black body, okay, so the observation was almost same, whatever graph was there, okay, regarding to, okay, that one is regarding to when we heat that black body. Okay, so their graph is almost same. Okay, what, that one is simple, in this one कि we are able to see that color only. Okay, whose wavelength is, या सिंपल जिसकी वेवलेंथ की जो होंगी क्या होंगी, रेडिएशन सबसे ज़्यादा निकलेंगी, तो वी आर एबल टू सी दैट कलर ओनली. ओके, तो दैट वन इज अगेन सेम ग्राफ इज फॉर ब्लैक बॉडी रेडिएशन ऑल्सो. बट ओके, व्हाट हैपन इन दिस केस, इन केस ऑफ इलेक्ट्रोमैग्नेटिक वेव थ्योरी, जो उन्होंने एक आपको सिर्फ थ्योरेटिकल कंसेप्ट दिया था. ओके, दैट कंडीशन एंड दिस ग्राफ, जो हमने जो ग्राफ इन्होंने ब्लैक बॉडी रेडिएशन के थ्रू जो ग्राफ निकाला है, ओके, ये वाला जो ग्राफ है ये आपका क्या कर रहा है, मैच नहीं करता. ओके, अकॉर्डिंग टू दैट थ्योरी, सिंपल वेव थ्योरी. ओके, अदर थिंग इज अकॉर्डिंग टू दैट वन, उनका जो ग्राफ था थोड़ा सा, दैट वन इज like this. Okay, means, okay, according like this one, but this one is a simple, okay, theoretical concept. This one was not experimental. Okay, experimental graph is this one. ओके, जस्ट सी कि एक्सपेरिमेंटली क्या किया, जब हमने हीट करा उसे एक पर्टिकुलर टेम्परेचर पे. ओके, तो दिस वन इज लैम्डा मैक्स एंड दिस कलर इज विजिबल. बट इन, ओके, जस्ट सी, ऑल्दो वेव थ्योरी एंड दिस ब्लैक बॉडी रेडिएशन वाली थ्योरी, दिस वन इज थ्योरेटिकली बोथ आर, ओके, समवट सिमिलर. जस्ट सी, थोड़ा थोड़ा सा ग्राफ कैसा है, सिमिलर है, बट वेयर दिस वन wavelength is minimum, means you can say where the wavelength is 0, okay, or either it's a less wavelength, in that case the intensity is high. Okay, this was theoretical concept, but practically it is different. Okay, so to solve out this problem, okay, Planck quantum, or either you can say Planck gave a theory. That theory was known as Planck quantum theory. Okay, now in case of Planck quantum theory, okay, Max Planck gave this theory, okay, to prove this thing कि that one is light have a particle nature. Okay, now in this one, according to, okay, now just see, according to Max Planck, this one is, first of all, that radiant energy is not emitted or absorbed continuously but discontinuously in the form of small packets of energy called quanta. Okay, EM theory में हमने क्या पढ़ा था? That one is energies are emitted, radiations are emitted continuously. Okay, that shows the wave nature. But Max Planck said no, that radiant energy is not emitted or absorbed continuously, but it radiate or discontinuously in the form of small packets of energy, that is known as quanta. Okay, now remember one thing, that if more number of packets, large number of packets, that one is known as quanta. And if we are talking about a single packet, energy packet, that one is known as quantum. And that is the reason this theory is known as Planck quantum theory, because इसने क्या कहा था, इसने एनर्जी बंडल्स की बात करी थी, छोटे छोटे पैकेट्स की बात करी थी. Okay, and that single packet is known as quantum. That's why this theory is Planck quantum theory. Okay, and in case of light, the quantum of energy is called photon. In case of light, that one is known as photon. Now, okay, he gave one relation also, that one is E is directly proportional to nu, means the amount of energy associated with quantum of radiation is directly proportional to frequency of light. And when you remove this sign, okay, we have one constant, and that is known as Planck constant. Why? Same, because Planck ne theory di thi, that's why it's a Planck constant. And you have to learn one value, that is 6.626 into 10 is to power minus 34 JS. It's a joule second. Okay, but just see, okay, in this one, either you mainly we will use this value only, otherwise we have another also, that is 3.99 into 10 is to power minus 13, okay, kilojoules second, okay, mole inverse. Now last thing, that one is the total amount of energy emitted or absorbed by a body will be some whole number multiple of quantum. Okay, that one is E is equal to n h nu, okay, where n is equal to 1 2 3 and so on. Okay, this one is regarding to what, that one is Planck quantum theory. And this concept, again, this shows it's a practical concept, and this theory was similar with that graph that we has obtained in black body radiation. तो theoretical और जो उसका ग्राफ वाला experimental ग्राफ था, वो आपका कैसा करने लग गया था, मैच करने लग गया था. तो this shows what, that one is light have particle nature. But as I told you कि later on we'll study what, that one is light has dual nature, particle as well as wave nature. Okay, thank you.